Right, so I hope it's visible. Can someone respond?
Yes, sir.
Okay, right. Well, so in the last lecture, we discussed about the introduction of subject. We understood how important it is to understand all the basics, and in your curriculum, in your complete engineering course, how much importance it's having, right? So in last lecture, we have studied that. Today, we will go ahead with the course outcome. I guess I told you the course outcomes in very brief. So today also we will discuss course outcomes in short, and then we will proceed for understanding what syllabus is involved in this. Right. So this is the course outcome. So basically, as I said, there are 6 units involved, and for every unit, I have identified one outcome. So after completion of every unit, there would be one outcome that is going to be acquired, right? So for first unit, which is completely kind of mathematical, you have to use the concepts like scalars and vectors and del operator, etc. So first unit, once we complete that, you will be able to utilize those mathematical concepts in electromagnetic field. So this is the outcome of first unit. Then after completion of second unit, you will be able to interpret the concept and solve the numerical of electrostatic field. See, basically this complete subject is divided into 4 groups, as I said. Number 1, it's electrostatic field. Number 2, it's magnetostatic field. Number 3, electromagnetic waves, means combination of both. And finally, the transmission line, right? So this first concept, that is electrostatic field, is covered in second unit. Then in the third unit, we will discuss about magnetostatic field, right? So after completion of that unit, you will be able to verify various laws of magnetostatic field, and also you will be able to solve the examples on it. Then we will summarize Maxwell's equation to interpret wave propagation. So when we comes to a wave propagation, so wave propagation means the wave itself will have some electric field and magnetic field, right? So EM field, we call it as EM field. So when it travels in the air, when it travels through some media, we have to analyze it, we have to interpret it with the help of Maxwell's equations, right? So Maxwell's equations are again most important part of this electromagnetics. Then we will see electromagnetic wave propagation in different media. And after discussing last unit, we will be able to have the knowledge of Smith chart, and we can determine the transmission line parameters. So these are all outcomes of our subject. So very quickly, let's move on to the syllabus. So in the last lecture, I asked you to buy a 200 pages notebook. So I hope everybody is ready with the notebook. I will give you time to write the syllabus only, because I'm not going to dictate anything throughout the course. I'm not going to ask you to write anything apart from this syllabus. So at the start of every chapter, you should be able to write the syllabus, right? So let's understand what contents involved in the complete subject, and then we will come to specific chapter. So in this particular unit, what things are there? We have to study the scalars and vectors. So most of you are aware of concepts like scalars and vectors, right? So we will revise those concepts, and then we will proceed for vector algebra. So this vector algebra consists of different operations between vectors. So that includes product multiplication, like dot product, cross product. Those concepts we will discuss in vector algebra. Then we will see the coordinate systems. So there are three coordinate systems. Number one, it's a rectangular coordinate system, which is also called as a Cartesian coordinate system. Then cylindrical coordinate system and spherical coordinate system. So these three coordinate systems we will discuss, we will compare, and we will understand the relation between those different coordinate systems. So at the end of that, once one point is given in one of the coordinate system, if you know the relation between coordinate systems, you will be able to represent that point in some other coordinate system, right? So that is important. You should know the relation between coordinate systems, and if the point is given in one coordinate system, you should be able to convert, you should be able to transform it into some other coordinate system. So that is the outcome. Then we will discuss differential length, surface, volume. See, in electromagnetics, the charge is always uh, available in a variety of configurations, such as point charge, line charge, or surface charge, or volume charge, right? So these are all charge configurations. So whatever things we are going to discuss in Coulomb's law, or let's say Gauss's law, these are all defined for point form of charge distribution, point configuration. So in practice, we have to understand line charge. So let's say if the charge is distributed over the line. So can we apply the Coulomb's law for that? Yes, we can apply the Coulomb's law for that. But yeah, so we can apply the Coulomb's law for line charge. We can apply Coulomb's law for surface charge if the charge is distributed over the surface, or let's say you have a sheet, and on that the charge is distributed. So in that case, Coulomb's law should be applicable. So how you can apply the Coulomb's law, which is already defined for point form? So for that reason, we should be able to understand the differential length, differential surface, and differential volume, so that we can, if you are having some length, you can split, you can divide it into small pieces, and you can consider those small pieces as a point charge, and finally you can integrate it. So for that reason, we must understand what is differential length, what is differential surface, what is differential volume, right? So I do not expect you understand whatever I said, but at least part of it should have reached to you. So differential length, surface, and volume, differential length, differential surface, and differential volume. Those mathematical concepts we will see in the first unit, and then in the second unit onwards, we will see how it can be used. And then point and vector transformations, right? So point, if it is given in a coordinate system, how you can convert it into another, and vector transformation. So all those things we will see in the first unit. Then comes electrostatic, right? So as I said, the first part of this first major block, you can say, of this course is electrostatic, right? So electrostatic begins with the basic fundamental law called as Coulomb's law, and then along with that, we will discuss electric field intensity, right? So we will see how Coulomb's law can be used for finding the force between two charges, and how that force can be used for obtaining the electric field intensity. So after discussing those two concepts, we will discuss electric field intensity due to different charge configurations, different distributed charges. Like just now I said, Coulomb's law basically defined for point charge. But in practice, we have different charge configurations. We call it as distributed charges. So that charge configuration, it can be line charge, surface charge, or volume charge, right? So all those things we will discuss here. Then we will discuss about the flux density, right? So flux, total flux divided by area, that gives flux density. Then we will discuss the del operator. So del operator will help you to find out gradient, divergence, and curl. You might have heard those mathematical operators, such as gradient, divergence, and curl. So we will discuss all those del operators in detail, followed by Gauss law and its application. Then there would be a divergence theorem, electrostatic potential, potential gradient, electric dipole. These are all terms which are related with the electrostatic. And I don't want you to take into the deep dive of this electrostatic, because every point requires 1 hour or let's say 2 hours for complete understanding, and don't want to feel you difficulty in the syllabus. So we will quickly move ahead. So boundary conditions we will discuss at the end of this unit. Then comes static magnetic field, right? So I told you second part of this would be a magnetostatic field. So third unit will cover it. Similar to the Coulomb's law, there would be analogous law available in the magnetic field also. So Biot-Savart law, which is basically used to identify, which is basically used to calculate the magnetic field intensity. Right. Then followed by that, we have Ampere's circuital law and their application. Stokes theorem is also there. So magnetic flux density and vector magnetic potential. So those things we will discuss. Very similar to the electric potential, there would be a magnetic potential. So we will discuss the difference between them and current carrying conductors in a magnetic field. Right, so we will find out torque on a loop, so you will understand basic working principle of motor and all that. So if the current is flowing through the coil which is placed in a uniform magnetic field, how it experiences a torque. So those things will be understood at the end of this unit. So energy stored in a magnetic field and boundary condition. So unit 2 and unit 3 basically covers electrostatic and magnetostatic respectively. That's all. And we are going to discuss those two units in a comparative manner. Means what here on first on the one side you will find electric field intensity. You will find analogous term that is magnetic field intensity. Here in this side you will find electric flux density. On this side you will find magnetic flux density. On this side you will find electric potential. On this side you will find magnetic potential, right? So those electrostatic and magnetostatic, those two concepts we will discuss in second and third unit respectively. That's all. So here we complete half, that is one section of your complete syllabus. Then comes a Maxwell's equation, and I told you Maxwell's equation basically gives the relation between electric field quantities and magnetic field quantities. So that's all about Maxwell's equation. They variety of equations are described, variety of equations are developed for this, and they basically gives you the relation between field quantities, right? So field quantities are like electric field intensity, electric flux density, electric potential. These are all field quantities. For magnetic field also, you have magnetic field intensity, magnetic flux density, and magnetic potential. So these are all field quantities, and Maxwell's equation gives you the relation between field quantities. So there would be a continuity equation, displacement current, current density, all those basic concepts we will discuss, and followed by that, we will see the Maxwell's equations in two different forms. One, it is integral form. Second one is point form, right? So integral form and point form. Point form is also called as a differential form of Maxwell's equation. So this is what about the Maxwell's equation. We will see those Maxwell's equation for various fields like time varying, harmonically varying fields also. And in the fifth unit, we will see basically how the wave is propagated, how this thing, electromagnetic waves are transmitted through the media, right? So wave propagation in dielectric and conducting media. This is the first point. Then modification in wave equation, then propagation in a good conductor, skin effect if the wave is propagated, if it is transmitted through different media. The skin effect means how depth of penetration we need to calculate, and that is nothing but skin effect. Then Poynting theorem, so it will give you the total power flow in a uniform plane way if electromagnetic wave is being transmitted through the medium. So next is a transmission line. So this would be the last unit, and as I said, this would be the fourth concept of electromagnetics, transmission lines. And I told you transmission lines are required for transmitting the electromagnetic waves, electric signals, right? So transmission line section as a circuit element that we will see. We will discuss the transmission line equations. We will see different constants involved in a transmission line, such as primary constant and secondary constant. So whatever R, L, C, G, conductance, admittance, impedance, everything we will discuss in this unit. Followed by reflection coefficient, transmission coefficient, VSWR, that is what we call as a voltage standing wave ratio, and impedance transformation on lossless and lossy media, and finally Smith chart. So with the help of a graph, how we can identify different characteristics of transmission line. So these are all things we are going to discuss in sixth unit, which is last unit of your EMFT. Now coming to the internal continuous assessment, as I said, there would be 25 marks of term work, and it will be based on minimum 8 tutorials based on that curriculum. Along with that, your attendance will be considered. It will have more weightage. It will consider the online test, right? So online test, attendance, your performance, and these 8 tutorials. So these all will have a contribution into the your 25 marks ICA. Then different books which are there. So as per university, they have recommended some of the textbooks and reference books. So I hope you will keep a note of it, or at the end of at the start of every chapter, I will tell you which book is to be referred. So if you want, you can take a screenshot of this. So these are the books you need to refer for electromagnetics field theory. So textbooks, I can say here, Electromagnetic Engineering by William Hayes, 7th edition by Tata McGraw-Hill. Another book recommended by university is Electromagnetic Waves by again Tata McGraw-Hill. Then J.D. Krause, Electromagnetics by J.D. Krause is another book which you can refer. And last textbook is Electromagnetic Field Theory and Transmission Lines. It's a Pearson edition, right? And reference books you can go for is like Electromagnetics Outline Series. It's by J. Administer, again by Tata McGraw-Hill. Then Problem and Solutions in Electromagnetics, it is another book. Electromagnetic Wave and Transmission Line, another book, reference book. So actually you don't have to refer all those books for electromagnetics. I can suggest which is not listed over here, but your university curriculum, your final examination is based on that book only, but it is not recommended into the syllabus. Let me tell you the name of that book. It's Electromagnetic Engineering by Sandeep Wali. So this note, I want you to note it down in the notebook. It's Electromagnetic Engineering by Sandeep Wali. This is a textbook. As far as previous examinations are concerned, all the questions belongs to this book, either from solved examples or unsolved examples. But anyway, it is going to be there from that book only. But they have not specified it here because it's a textbook, and already 4 textbooks 4 good textbooks they have mentioned here. So coming to the first unit, so you can take a note of this by the time. Let me check how many are present because I'm not able to see the screen. Okay, 42 are present today. Great. So I expect everyone should take a note of this syllabus of first unit. Unit 1, vector calculus. Total 4 hours are allocated for this unit. So the contents of this unit are scalars and vectors. Please note down this. Scalars and vectors. As I said at the start only, I will not be dictating anything throughout the semester, but I hope every one of you should take a note of this part, because unless and until you know the syllabus, you will not be able to study anything. Right. So I expect all of you to take a note of syllabus. Unit 1, vector calculus. So only 4-5 points are there, and total time duration assigned for this unit is 4 hours. So within 4 hours, we are going to finish with first unit. This includes scalars and vector. Please note scalars and vectors, comma, vector algebra, comma, coordinate systems, comma, differential length, comma, surface and volume, comma, point and vector transformations. Right. So I hope all of you have written this. Now let's move ahead. Okay, again, syllabus. Now for this particular topic, I personally recommend this electromagnetic engineering by William Hayes as a book, as a reference book. And of course, there would be a hidden book, which I already said, it's electromagnetic engineering by Sandeep Wali. So I hope every one of you will have a copy of that book, Electromagnetic Engineering by Sandeep Wali. Right. So with that, let's understand what things are there. So partially, I have already covered most of the things involved in this. About title of the chapter, right? So title of the chapter is like vector calculus, right? So vector calculus, if we split this into two terms, right? So vector means it's a kind of quantity which will have magnitude and direction. Right. So this is the meaning of vector, and calculus means different relation, different operations between vector quantities. I think is nothing but vector calculus. Right. So this is about the title of chapter. Then central idea. So let me tell you, in university examination, there would be very less or no questions on this unit. Do you heard what I said? In the university examination, there would be very less or no questions on this unit in university examination. But still, let me make one more statement here. Unless and until you have good practice of first unit, you will not be able to succeed to understand the future or further units like unit 2, unit 3, unit 4. Unless and until you understand this unit, you cannot study further part of this course, further part of this subject. I have made 2 sentences, which is takeaway of today's lecture. Number 1, there would be very few, there would be very less questions, or there would be no questions on this unit. But until you study this, you will not understand further part. Until you study this vector, you will not be able to identify the electrostatic field. You will not be able to calculate magnetostatic field. See, somebody's on unmute. Please check who is on unmute. Okay, fine. Right. So that is what I wanted to convey. So central idea of this chapter is basically the different operations between vectors, del operator, and then line charge, surface charge, volume charge. These are all charge configurations and differential lengths, differential surface, differential volume that we will discuss in the unit. And coordinate system basically, which is very important. Coordinate system, to understand the coordinate system we should have a proper imagination, let me tell you, because everything is going to be a virtual. So you should be able to imagine with a three-dimensional perspective. So I will help you during that mechanism, but understanding of coordinate system is very important for discussing the electrostatic and magnetostatic concepts. So now coming to the outcomes, as I discussed the importance with that only. So outcome, you will, at the end of this unit, you will be able to define and recognize different coordinate system and apply divergence, gradient, and curl to EM waves. EM wave means electromagnetic waves. So these are the outcomes of this particular unit. Now, so to begin with, so since it's not a part of syllabus, so you may consider this as a beyond syllabus, but it's a kind of revision. So I hope everybody is listening. I hope everybody is having a keen eye on the screen. And these things which are already studied by you, not a part of our syllabus, still I am considering it here because you should require the reference of those formulae, let's say differential formula, integration formula, right? So trigonometric functions, etc. So we will have a quick revision on those formula, and then we will proceed to understand two terms called as a vector and scalar, scalar and vector, right? So here with differentiation formulas, very quickly we will revise it. Differentiation of any constant term k is 0. Differentiation of f of x plus minus g of x, it's equal to f dash of x plus minus g dash of x. What is f dash and g dash? G dash dash indicates differentiation of that function. So f dash of x plus g dash of x. This would be the differentiation of this. Then d by dx of k into f of x. So differentiation of this is equal to k into f dash of x. Dash indicates d by dx. Dash means d by dx. It's a differentiation of that function. Then next comes product. So d by dx of f of x into g of x. So answer of this is f of x into g of x plus g of x into f dash of x. Then we have d by dx f of x divided by g of x. So this is equal to g of x into f dash of x minus f of x into g dash of x divided by g of x bracket square. So these are all differentiation formulae. So we have some more, right? So d by dx f of g of x, it is equal to f dash of c. The things will not reach to you if I read everything, but I will keep the slide open. I expect you to read the slides. I expect you to just try to recall those formulae, because these are all you have studied in mathematics already. I'm not dealing with that. I'm not trying to tell you the syllabus point, but just because we require some of the reference from those formulae, I want you to go through those formulae, right? So I will not read. I have kept the slide open. You can observe, you can check, Try to remember those formulae like d by dx sine of x is equal to cos x, right? So derivative of sine x is cos x, derivative of cos x is minus sine x, derivative of tan x is sec square x. Then we have derivative of cot x is minus cosec square x. Derivative of sec x is sec x tan x. Derivative of cosec x is minus cosec x cot x. Derivative of ex, e raised to x, right? So derivative of e to the power x is equal to e raised to x. Then derivative of a raised to x, it is a raised to x log of a. Then log of x, derivative of log of x is it is equal to 1 upon x. So some inverse trigonometric functions and their derivatives. Right, so then comes the integration formula. So in the integration you will have this integration of dx, like it would be x, right? Then integration of x raised to n, it would be x raised to n plus 1 divided by n plus 1. Then integration of dx by x, it's log of x. Then e raised to x dx, it's e raised to x, right? So these are all integration formulae. Integration of sin x is minus cos x, integration of cos x is sin x, integration of tan x is minus log of cos x, integration of cot x is log of sin x, then integration of sec x is log of sec x plus tan x, integration of cosec x is minus log of cosec x plus cot x, integration of sec square x dx is equal to tan x, integration of cosec square x is minus cot x, integration of sec x tan x is sec x, then integration of cosec x cot x is minus cosec x, and yeah, some additional formulae. Right. Anyways, I'm going to share this with you immediately in the WhatsApp group. So if you want to make a practice, if you want to note it down somewhere, because I have tried to include all the mathematical background which you require from the previous subjects like M1 or M2. So in the first lecture only, I told you it's a kind of mathematical subject, but the moment I said that, you may be in the impression that we will require some mathematical background. No, you will require only those formulae. So I'm going to share those formulae with you. So if you want, you can take a note of it. Just a minute. Yes, now you will find all the mathematical things on the slide lecture 2. Right, so I hope let me stop the sharing first. Yeah, now we have 20 minutes left, and I want every one of you to introduce yourself, so you don't have to be a little kind of shy or something. Let me give you the skeleton in what way I want the introduction, and what way you can follow. So in the chat box, I will put it what is expected. So I want you to introduce yourself with respect to your full name, So I'm giving you the pointers. So I want those points to be answered in your introduction, right? So that is your full name, then native place. I want your native place. Then since you have done diploma, you are in a B division, so diploma college, then 3 years aggregate. So if you calculate all the 6 terms and if you take the aggregate percentage marks obtained in diploma. So okay, yeah, those 4 points, with respect to those 4 points, you have to introduce yourself, right? So those who will introduce, only their attendance will be marked. So let's begin with roll number 1. Are you there?
Yes, sir.
Yeah. So you need to turn on the camera. Let your classmates see your face. Let us all see each other, so that because classroom connect is missing, and we are not even able to identify when student comes to the college. No, we are not able to identify the candidates. Since I hope you know, I am the I'm the person who is looking after placement activities, and I must know the people personally, in fact, right? So I should know the faces at least. So I want every one of you to turn on the camera and introduce yourself with respect to those 4 points. You have to answer those 4 points.
Yes, sir. Good morning, sir. I am Shivani Hanumantarekar from Kurdwadi, and I completed my diploma technical campus in Sangola, and my diploma aggregate is 91.47.
Okay, fine. Roll number 2.
Thank you.
Yes. Roll number 2 is there. Roll number 3. Roll number 3. I'm just taking the attendance parallel, yeah. So I'm marking roll number 2 and roll number 3 as absent. Roll number 4.
Yes, sir.
Yes, go ahead.
Good morning, sir. My name is Rohini Pavan Bandare. I am from Latur, and I got 60% 12. Thank you, sir.
Okay, and diploma college?
No, sir. Regular student.
Okay.
Posted A division.
Okay, fine, got it.
Thank you, sir.
Next. 5. Roll number 5.
Good morning, sir. I am Sakshi Shoshan Bharma from Aidari. I completed in diploma in SVSMDS Polytechnic, Akkalkot. My diploma percentage is 87.
Okay, fine, great. Next. Roll number 6.
Good morning, sir. Myself, Naneshwari Balasaheb Das. I am from Kurdwadi. I have completed diploma in Sweri College Polytechnic, Pandharpur, and my diploma aggregate is 81.
Okay, great. Next. 7. Roll number 7. Roll number 8.
Good morning, sir.
Yes, good morning. Go ahead.
Good morning, sir. Myself Shefali Ajay Gaddam. I am from Solapur. I am completed my diploma from VVP Polytechnic Solapur, and my diploma percentage is 85.53.
Okay, fine. Great. Roll number 9.
Hello, good morning, sir.
Good
Myself
morning.
Trishti Satyavan Javrai, born and brought up from Kudwadi. I have completed my diploma education for 40% marks in diploma.
Okay, great. Next. Roll number 10. Roll number 11. Roll number 12. Hello. Hello. Am I audible?
Yes, sir.
Yes, sir.
Roll number 10, 12. Roll number 10, 11, 12, 13.
Yes, sir.
Yes, go ahead.
Good morning, sir. My name is Priya Jakkappa Kote. I am from Mangalweda. I completed diploma in Shivaji Polytechnic College, Sangola in CSC, and diploma mark is 81.40.
Okay, great. 14. Roll number 14.
Yes, sir.
Yes.
I am Shreya Kulkarni from Pandharpur. I have completed my diploma in Fabtech Technical Campus, Sangola, and I got 90.76% in diploma. Thank you,
Okay.
sir.
Yeah. 15. Roll number 15.
Yes, sir. Myself Priyanka Balasu Lendwe. I am from Kauthali. I completed diploma in Sweris College of Engineering, Polytechnic, Pandharpur. Diploma aggregate 83.37.
Okay, great. Next, roll number 16.
Yes, sir. My name is Amruta Rajbhav Lokre. I am from Suste. Diploma completed Sweri College of Polytechnic and aggregate mark diploma 80%.
Okay, fine. 17. Roll number 17. 18. Roll number 18.
Good morning, sir. My name is Smita Chutokule. I am from Sangola. Diploma completed in Shivaji College, Sangola. Diploma percentage is 73.30.
You have given roll number 18. You have given the introduction, right? We
Yes,
could
sir.
not hear. Your camera is also off. Yes.
My name is Smita Chutokule. I am from Sangola. Diploma is completed in Shivaji College, Sangola. Diploma percentage is 73.30.
Okay, great. Roll number 17 if you want to, because in the chat box you have written. Roll number 17. Roll number 17.
Yes, sir.
Yes, introduce yourself. Your camera is off.
Yes, sir.
Pooja Lokhande, you are not audible. Your camera is off.
Yes, sir.
You are saying only yes, sir, no, sir, but you are not responding. We expect you to introduce yourself. You are not speaking anything. Yes, go
Sir,
ahead.
audible.
Yes, it is audible. Ma, असणार की. ठीक आहे. I guess she is facing a network issue. Roll number 19. Roll number 19. Hello, roll number 19. 20. Roll number 20.
Yes, sir. Good morning. Good morning, sir. I am Meenal Shrikant Hamane from Pandharpur. I completed my diploma from FabTech Technical Campus and I got 72.71%.
Okay. 20. I guess 20 didn't. 21.
Yes, sir. Good morning, all of you. My name is Ashwini More. I'm from Suste. I'm a regular student.
Okay. 22.
Very good morning, sir. Myself, Rupam Revannath Muluk. I am from Barshi. I have pursued my diploma in computer engineering from Government Polytechnic Pune, and I have aggregate of 71.80%.
Okay. Next, 23. 23. 24.
Good morning, sir. Myself, Shweta Nipse, from Sweri College, and my diploma completed in computer engineering, computer engineering, and SIT College, Polytechnic Ichalkaranji, and my percentage is 74% in last semester.
Okay, fine. 25. Roll number 25. 26. 26. 27.
Yes, sir.
Yes, go ahead.
Good morning, sir. My name is Rituja Sanjay Sheke, and I'm from Shadeford, and I have done my 12th from MVA Junior College Shadeford and got 67 marks.
Okay, fine. 28.
Yes, sir.
Yes, go ahead.
Good morning, sir. My name is Pratibha Prasad Surivanshi. I am from Sangli. I completed my diploma from MD Jadhav Polytechnic Bhose in stream of CSC department. I got my diploma percentage is 65.
Okay, fine. Next, 29.
Yes, sir. Sir, good morning.
Good morning.
Sir, myself Vaishnavi Vidyadhar Swami from Pandharpur. I completed diploma in SEM, Sweri College of Engineering Polytechnic, and I got 89% in diploma finally.
Okay, great. Next, 30. Roll number 30. 31. 31. 32. 32.